Yeah. Uh, Hi again. Sorry for the interruption. Someone actually knocked my door, and then I realized it's not for me. Anyways, we're actually talking about the risk. So, for instance, you actually bought a TV, okay, and you know that the probability of the failure of the TV is point 0, point 1. Okay, so what is that? Point 1 per year. Okay, what is that? That means it's point 1 means 1 by 10. Okay, it does means 1 by 10 per year. Okay, so that means 1 out of 10 TV can be fail within a year. Okay, so that is the probability of failure. Now the consequence is, for instance, the price of the TV. For instance, your TV's price is CAD $1,000. Okay, so when you actually multiply these two, you'll get a number. You'll get a number like dollar per year, something like that. For instance, okay, or like, I mean, if you actually like another thing, so something, some number. So for instance, here you will get the total, like, I mean, total value would be 0.1 times 1000. That means you will get a number is 100. Okay, so this is a benchmark. So this we called is the risk. Okay, now if you compare this with, for instance, with lower brand TV, for instance, like no name TV, no name brand TV. Okay, now no name brand TV is risk could be higher. It could be like a point 0.5 per year, but the no name TV's price is much lower also. Okay, so it would be like cat, for instance, within $500 you will get. Okay, so what would be the what would be the risk in that case? The risk would be zero point 0.5 times 500. That means 250. So that means although the price is lower, still the risk is higher in this case. Okay, so for instance, this one is a good brand for like Samsung or like LG, or any kind of, like, I mean, where Sony. Okay, any type of good brand, but so that's risk is, for instance, like the 100. But in this case the risk is for the no name brand in here is like 250. So that means if you actually want to invest on this whatever name brand is in here, so that means the risk is more higher than this branded value one. So that's why we spend more monies, but still we want to get the better good brand TV, so that we have minimized the risk. Okay, so this is actually one of the example we actually calculate the risk. So primary goal of the risk management is to eliminate or to contain the POF and COF. That means if you reduce this number or this number, so your risk could be also reduced. Okay, for instance, like just giving an example, Samsung is actually trying to reduce the price with the same number. Okay, whereas Sony, they actually try to reduce this number, the probability of failure. That means making the TV much more better. Okay, so there is less failure, but they will fix the price. So the risk would be, in a sense, would be removed. So that's how the different company, I mean, our goal would be to eliminate either the probability or to or the consequence of the failure. Okay, so that's the main goal of the risk management. Now, what is probability of failure? Probably from this example, you already know that, we already have learned. So but still, let's go to the um, example. I mean, the definition. So probability of failure means how likely the risk will occur. okay, and what are the chances of the failure. And the COF, or like consequence of failure, means the result of the failure or loss of the life or the property. For instance, if the TV is gone, so you'd lost, like the TV is failed, or like um, it don't work, so you'd lost this amount of money plus the shipping cost, and there is some other additional costs also. Okay, so this would be the problem of the risk. Now, how we can actually mitigate the risk? We would need to lower down these two. Okay, so the risk mitigation is IM, that means the integrity management. So integrity management actually works to reduce the failure probability, or like the probability of failure, okay, times HCA, or high consequence area. Okay, so high consequence area means like to um, contain the consequence of the failure in a big high consequence area. For instance, the downtown Sydney got more people, more properties, more valuable, something in there. Okay, but if it happened, if any kind of incident happened in the middle of nowhere, that would have some less consequence. It still have some consequence, like environmental consequence, but the consequence of like damaging the public property or people's life would be even less values. Okay, so that means this is the HCA. Okay, so this is how we can actually mitigate that. We will actually come that to again later. Now, the probability of failure, or POF, of each threat is based on what? Based on the examinations of the pipelines. Okay, just like the doctors actually examining your body and try to find like what is the, if you feel sick, you'll go to the doctor, and doctor actually give you the examination. So they do different types of exams, like the x-ray, or like a ECG, or they will actually give the stethoscope and try to find what happened to your body. This, or like the visual exam. The same way we do the examinations of the pipeline. Okay, we will actually do the different types of examination. For instance, ILI, or in-line inspection, we call it ILI. Okay, so it also known as pigging. Okay, so we actually send a robot inside the pipeline, okay, that do the inspection and give us the data, like if there any problem or not. Another is ECTA. Okay, this type of the examination, hydro test. So these are the direct examination of the pipeline. Now, for the direct examination, you actually do the examination, like you select the pipeline segment and go in there and check the pipeline if what is work. So direct examinations is very effective, but the problem is it is expensive. Okay, so that's why one of the reason we do the statistical analysis for the failure data. Okay, so what does the statistical analysis mean? Statistical analysis do not do the direct examinations, but what it do actually, it gather the failure data, and then we make a statistical model. Okay, develop a statistical model to on the asset attributes, and we use the data, and we by using the model we actually predict. Okay, we predict the failure, and from the probability of failure. Okay, and from there we can actually know, like, okay, so this area is much more vulnerable, and we have to examine this area, so that you don't have to do the direct examinations for like millions of miles of pipeline. What you can do, you can actually squeeze it down even more further. Okay, and except for the millions of miles of pipeline, you can do, for instance, 1000 or 2000 miles of pipeline. Okay, so that's why we do this statistical analysis to make it down, like make it more accurate, so that we don't have to invest lots of money on direct investigation. Okay, so what are the data set we need? We need the design documents and codes. We need PHMSA data, PHMSA incident and leak set data that we can use, since PHMSA is open source, and we can use all this leak data. Okay, we can use clients asset performance, the histories, ILI, and other examinations based on the similar asset in the network. Okay, now These are all about like the probabilities. Now let's talk about the consequence. So what are the consequences we might have if any kind of incident happen for the pipeline? For instance, here, if any incident happen, okay, so what will be the consequence over these areas? Okay, what will be the impact of these areas? Like for the health and safety consequence, there are physical damage and economic loss, environmental consequence, regulatory consequence, and corporate image is one of the severe consequence. Okay, so for the health and safety, there could be injury, the fatality. Okay, for the physical damage and economic loss, there will be property damage, service disruption, commodity loss, and the repair cost. For the environmental damage, there will be emission, and there could be the rehabilitation also. Okay, for the regulatory perspective, they would have economic and technical consequences. Okay, that means like the economic to the regulatory means the company will get sued by the regulatory, by the government actually. Corporate image, well, as you well aware about the public opinion and the government relations. So if any incident happen, lots of people will get angry, and like there will be a big news over the time, and they will, the share market of that company would lose. For instance, BP, after the Deepwater Horizon, BP lost its a huge chunk of the share market, and it still is suffering for that loss. Okay, so that is one of the most important part of the consequence. Now, as you know, like the risk mitigation is equal to integrity management times ICA. So let's talk about the integrity management and the ICA a little bit. Okay, sorry, the HCA a little bit. So the integrity management is a concept is based on the control and elimination of risk by assessing the probability of failure. Now, the probability of failure and the consequence establish the level of risk. Okay, and the integrity management is a systematic procedure to address the probability of failure in high consequence area, which is a threat in high consequence area. Okay, now any event or condition which is a threat to the integrity also increase the probability of failure, which increase the risk, right? If the POF or the probability of failure increase, then the risk also increase. What is HCA? When the probability of failure is high in a component that can have higher consequence in terms of loss and damage to lives or the property, that this it is termed as HCA component. Okay, so these are the relationships between the integrity management and the risk management. Now, risk assessment is a measuring process, and a risk model is a measuring tool. So these are the difference between like the risk modeling and the risk assessment. So risk assessment program could be either performance based or perspective based. Now the perspective based program is a tool that complement the integrity management program by organizing the data and being helpful in the integrity management decision making process. But the performance based program that organize the data and the priorities and the plan of action, okay, and it decides on the timing and the selection of the inspection method and the prevention of the mitigation plan. Okay, so the performance based program is more, I would say, active, but both types actually are important. But one thing is for sure is like either you go for the perspective based program or the performance based program, the data is very important. Okay, so whatever when we actually do, the data collection is very important. So what types of data collection is important to conduct the risk assessment, which is a part of the pipeline integrity system. Okay, what are those data? So the collection of data is the primary step of the doing the analysis. Okay, so for a successful risk assessment and the integrity management program, data collection is a very important part of this. And what the type of data we need the location data. What is the location data? The incident location. Okay, operational data, that means what are the pressure, temperature of the operating condition during the incident. The design data, that means the, for instance, like the year of construction, material of building of the pipeline, or like what is the minimum yield stress, if the what is the manufacturing process of the pipeline, if there any what is that, is there any welding or not, okay, if there any previous history of the of incident of that pipeline. There are so many original design data you can actually collect. Okay, ILI data, that means in line inspection data. That means the robot actually gives any incident indication or not. For instance, if when you actually run the robot inside the pipeline, okay, that does that give some indication like, yeah, there are some groovings or there are some corrosion is started. Okay, just like in our human body, we had the fever, so that is a type of like indication, like a bigger infection or something is coming to our body. So is there any kind of indication like that is given, or like chemical program data, or like, I mean, when we actually inject the chemical program, so from there, if we have any types, for instance, like the corrosion inhibitor, so what is the dose of corrosion inhibitor we actually gave, like the cathodic protection data. Okay, so in order to save the pipelines from the corrosion, we actually gave cathodic protection. We'll actually learn it about it the next chapters. Okay, so if we have any enough data on the corrosion cathodic protection or CP, coating data. Now, if the what type of coating is in there, is it how much effective it is, or like, I mean, how old is the coating, or like the type of coating, is there any history that the coating can get scrap off. Okay, the monitor and inspection data. Okay, if there any inspection has been done in that pipeline. So gathering all this data will give much more confidence on us. Okay, which will give us more confidence that, okay, so the integrity, pipeline integrity management, to the pipeline integrity management program. Okay, now the data collection. This is the statement from USDOT, or Department of Transportation, or US code. Okay, and that actually gave us like the what are the segments we are actually thinking about, and what would be the consequence of the failure of the pipeline. Okay, and the data collection, or like the integrity program, it emphasizes on the four different pillars. Number one is the identification of the hazard. Number two, the collection of data. Number three, the detailed analysis. And number four, the consequence of failure and risk mitigation. Okay, so these are the main pillars of the ideal integrity program. Okay, now design, as we talked about the different types of data in here. Okay, the collection of data. What are the types of data? Okay, you remember, like here we're actually talking about the different types of data. So like for the design data, what types of design data we can have? Wall thickness, manufacturing diameter, manufacturer diameter, date of manufacturing, installation date, etc. Operational data, flow rate, MAOP, and others. Inspection data, what are the types of inspection has been done? Okay, the construction data, the year of installation, welding, bird depth, crossing type, pressure test, coding data, soil report, installation of CPE, coding type. So these are the different types of construction data we have. Now, there are different risk assessment tools. We have the HAZUP. HAZUP is a simple and structured method for hazard identification and assessment. P&IDs, PFD, material flow diagram. So from there we can actually develop the HAZUP. Fault tree analysis is a deductive reasoning technique to determine the occurrence of any undesired event analysis. Okay, so it's also known as FTA, right? Event tree analysis is a top-down logical modeling that's give us the reason of the single initiating events, okay, and it gives the probabilities of the outcome and of the overall system. FMEA is an examination based, like it's also known as a failure mode and effect analysis. And what if analysis is a technique that invokes the question, okay, that raise the question, begins what if this happens. That means to identify the hazard. Okay, so these are different types of hazard assessment tools. So this is how the haze up actually works. Okay, the hazard and operability study, or haze up, actually works in this way. Now, the risk assessment methods. There are two major risk assessment methods. Okay, we have qualitative risk analysis and the quantitative risk analysis. And the quantitative risk analysis is also known as probabilistic risk analysis or assessment, okay, or PRA or QRA. Okay, so qualitative risk analysis is something like, it definitely predict the undesired situation of the process system, and it identify the potential chemical and mechanical hazards by the hazard study and process hazard analysis, etc. Whereas quantitative risk analysis evaluates the likelihood of occurrence of incidents, and it finds the specific cause and the consequence of potential hazard along with their contributions, and it evaluates the effectiveness of control measure and design modification of the process system. It uses probability theory, and it's also, that's why it's known as probabilistic risk analysis or risk assessment. Okay, it uses FTA and ETA for analyzing the cause and consequence of the incident. Now, for the quantitative risk analysis, the risk is expressed with the frequency or the probability, as we know as POF. Remember from the last slides, okay, and it's also the consequence of the incident. Now, here are like all the things, like how we can calculate the quantitative risk analysis. The first thing, we need to know the failure rate. From the previous example, we know is it 10 by 10, or like 0.1 per year. So that is the failure rate, is known as the lambda. Okay, now how we can actually calculate the probability of a component that will not fail during that time interval is using this. This is how we can actually do that. Okay, so if this is the failure rate, we can actually put it into the time, like within the time, and this is the formula for it, and the probability of failure is this formula. Okay, so this is the exp or exponential function, or e to the power x is also called. So that means exp minus lambda t, that means e to the power minus lambda t. Okay, so this is the case. Risk assessment tools. So there are different types of risk assessment tools we have, but here is one of the example. So risk means like loss of function or loss of containment. If it's a loss of containment, then it can be like by the leakage or rupture. If it's the leakage, then it could be pinhole, medium, or large. If we choose the pinhole, then it can like, is there an ignition, no ignition, or explosion? That means this is how we can actually pinpoint. Okay, so this is the how it actually happens. So for this reason, the whole risk we can calculate in here. We'll get a number, and that number will give us the indication of the risk. So this is the topic 5. So we'll actually check the topic, the next topic. So stay tuned with us. Thanks.